Alright guys, B exercise. Next question. That's question number 15th in continuation. So just talking about the B exercise. 15th sum. The question is, points A and B have coordinates 3, 5 and xy respectively. So just again that same diagram, I know only this, I know nothing else. You have A, you have B. The point is 3, 5 and the other point B is x, y. Has the midpoint 2, 3. Midpoint, let it be P, 2, 3. You have to find the coordinates of B. Midpoint means obviously distance AP is equals to distance BP. But not required, just knowledge purpose. I always start from the center. According to midpoint formula, 2 is equals to 3 plus x upon 2 and 3 is equals to 5 plus y upon 2. What I've done is, just like your section formula, I started from the center. So the x coordinate is x1 plus x2 upon 2. Y is equal to y1 plus y2 upon 2. That's all I've done. Right, cross multiply. 4 is equals to 3 plus x. 4 minus 3, that's 1. So x is equals to 1. Cross multiply. 6 is equals to 5 plus y. 6 minus 5, y is equals to 1. So the coordinates of B, which is x, y, is 1, 1. That's it. 16th for y'all. A, B and C are the vertices of a triangle ABC. L is the midpoint of AB and M is the midpoint of AC. Show that LM is equal to half of BC. Simple question, very simple. Let's break it now. It's nothing great in the sum. ABC are vertices of a triangle and the three vertices given to me are 5, 3, minus 1, 1 and 7, minus 3. L is the midpoint of AB, M is the midpoint of AC. Prove that LM is half of BC. TPT means to prove that LM is half of BC. This is actually a midpoint theorem. If you have studied 9th standard, yeah, if you join the two midpoints according to midpoint theorem, LM will be parallel to BC and LM is half of BC. Just for knowledge purpose. 9th standard we had a chapter called Midpoint Theorem. Yeah, so you should have known about it. And it's simple. What you do is, first get the coordinates of L. Let me call L as x1, y1, x2, y2. So we start with, you keep your head this way in an inclined manner. x1 is equal to minus 1 plus 5 upon 2. Right? So I have x1, you start from the center. Minus 1 plus 5 upon 2. And y1 should be, y1, this is going to be 1 plus 3 upon 2. 1 plus 3 upon 2. So x1 is equal to 4 upon 2. y1 is equals to 4 upon 2. So the coordinates of L, which is basically x1, y1, are 2, 2 respectively. Yeah. So I have obtained the coordinates of L. On a very similar note, you obtain the coordinates of M. Come on guys, come on. x2 is equal to 5 plus 7 upon 2 and y2 is equal to 3 minus 3 upon 2. So I get x2 is equals to 5 plus 7 over 2. So x2 is equals to 6 and y2 is equals to 0. So can I say my coordinate of M is going to be 6, 0. Fine. So once you get L and M as the coordinates, can you find LM distance with using the distance formula? Yes. So the distance LM is going to be root of, come on guys, this is 6 minus 2 the whole square plus 0 minus 2 the whole square. What I've done is I've basically used the formula. That's it, nothing great. Just subtraction of the x's whole square and subtraction of the y's the whole square. So LM distance, guys, is going to be 4 square plus minus 2 the whole square. It eventually lands me up to 16 plus 4, which is 20. 20 can be written as 4 into 5. That makes it 2 root 5. So LM is 2 root 5. Find the distance of BC. Okay, if you again use the distance formula for BC, come on, BC. 7 minus of minus 1. That's 7 plus 1 the whole square minus 3 minus 1 the whole square. So you get BC as root of 8 square plus minus 4 square. 64 plus 16, 80. 80 can be written as 16 5s, which is 4 root 5. Divide both of them. That's it. Divide. Come on, come on. LM upon BC, 2 root 5 upon 4 root 5. That's it. Cross multiply. Can I say LM is equals to half of BC? Hence proved. So we have spoken about it. It's a combination of two things. Midpoint formula plus distance formula. Nothing great, right? Okay. Next question. Number 17th for you all. It was just a bit magnanimous sum. Nothing special about the previous sum. 17th. You have been given a diagram for this question. We have been acquainted with such a diagram prior. Yes? Okay, the diagram is, we have this coordinate on the y-axis and b coordinate on the x-axis, and I on an instantaneous mode will say, oh, this is 0, b. Oh, this is a, 0, because the point is on the y and the point is on the x. Come on. On the y, x coordinate is 0. On the x, y coordinate is 0. It should come in sleep also, all these things. Okay. I have been told that there is a point P, which is the midpoint, minus 3, 2. Find the coordinates of A and B. Very simple. Very simple. Use midpoint formula. Minus 3, always start from the center. This statement, I must have reiterated more than 10 times. And in spite of me repeating over and over again, if you don't follow it, you should leave. You should take penance. Go. You leave studies, leave everything. Come on. Minus 3 is equal to A plus 0 upon 2. Just a midpoint formula, yaar. And 2 is equal to y of this plus y of the other upon 2. That is 0 plus b upon 2. Cross multiply. Minus 6 is equals to A. 4 is equals to b. So if I happen to write down the coordinates, A, which is 0, b, should be 0, 4, and b, which is A, 0, should be minus 6, 0. These are my coordinates of A and B. Right, a small question to solve. Go through these three. We have a lot more to solve. Next question. The question is, A, B, C are vertices of a triangle. Find the length of the median through the vertex 3, minus 6, which is one of the vertex out of the 3 vertices. So let's begin. A triangle given, ABC. Let's say the vertex A is minus 5, 2. Vertex B is 3, minus 6. And the vertex C is 7, 4. The question demands, find the length of the median through this vertex. That means this is my median. Let's say it is meeting at D. I have to find the length of BD. Now median means this blue color divides AC into equal parts. That means, can I say D is the midpoint? That is the significance of a median. D. So I can say that if D is the midpoint, because BD is the median, use the midpoint formula. Let the coordinate of D be x comma y. Start from the center. X is equal to, it's a midpoint of AC, minus 5 plus 7, the whole upon 2, and y is equals to, here the y of this plus the y of this upon 2. So I get x is equals to 2 upon 2 and y is equals to 6 upon 2. So x is 1 and y is 3. So the coordinate of D is going to be 1, 3, not over. I need to find the length of this median. The length means the distance. So I can say the distance of BD, it is root of x2 minus x1. So you can say 3 minus 1 plus minus 6 minus 3. So that makes it 3 minus 1 is 2. 2 square is 4. Minus 6 minus 3 is minus 9. Square is 81. So the length is going to be root of 85 unit. That's going to be the length of the median through the vertex 3, minus 6. Next question. Let's go on. 19th. One end of the diameter of a circle is minus 2, 5. So let's start doing it now. So we have a circle and let's say this is a diameter, center. One of the end is minus 2, 5 and find the coordinates of the other end. You have to find the coordinates of this. Again, A and B. Let this be x, y. And I have been told that the center of the circle is 2, minus 1. Such a simple question. Center means obviously O is the midpoint. Use midpoint formula. Start from the center. 2 is equals to minus 2 plus x upon 2 cross multiply. 4 is equals to minus 2 plus x. Minus 2 goes on the other side, becomes plus. X is equals to 6. And minus 1 is equal to 5 plus y upon 2. Cross multiply. Minus 2 is equals to 5 plus y. 5 goes on the other side. Minus 2 minus 5 is equals to y. So y is minus 7. So the coordinates of the other point are 6, minus 7. That you have to write it in a statement form. That's it. 20th question. A, B, C and D are the vertices of a quadrilateral ABCD. Find the coordinates of the midpoint of AC and BD. Give a special name to this quadrilateral also. Nice question. Really nice question. So in the 20th sum, A, B, C, D are vertices of a quadrilateral. So A coordinate is given as 2, 5. B is 1, 0. C is minus 4, 3. And D is minus 3, 8. Okay. These are the diagonals. They are asking me find the midpoint of BD and AC. That is midpoints of AC and BD, the diagonals. Let's begin. Let's start with the midpoint of AC. Let me call it as P. So I can say let P be the midpoint of AC. So use the midpoint formula. Let me call this P as x1, y1. So come on, x1, the P, the center, the P, x1 is equal to 2 plus minus 4. That's 2 minus 4 upon 2. And y1 will be 5 plus 3 upon 2. That's going to be 8 upon 2. And this is going to be minus 2 upon 2. So coordinates of P, which are the midpoints of AC, is minus 1, 4. Alright. Let's start with coordinates of BD. Let Q be the midpoint of diagonal BD. Q is x2 comma y2. Fine. So out here, Q is somewhere in between. Use the midpoint formula. X2, the point Q, x2, minus 3 plus 1 upon 2, and y2, 8 plus 0 upon 2. So that's going to be 4, and that's going to be minus 1. Oh my God. Oh my God. Can I say that the coordinates of P and the coordinates of Q are the same? So if the coordinates are the same, that means the diagonals bisect. The diagonals bisect at the center, because they both are now not P and Q separate. They are the same coordinates. So that means, can I say the coordinates, that is the midpoint of AC and the midpoint of BD is the same. So the diagonals bisect at the center. So it has to be a parallelogram. In a parallelogram, the diagonals bisect. All right. It's not over. Because even in a rectangle, the diagonals bisect. Even in a square, diagonals bisect. So even in a rhombus, diagonals bisect. So I don't think so I'm in a position to yet speak much more about it. So what you do is, after this, you find the distance formula. You find this, I'm not doing it, I'm sorry. Use distance formula 6 times. Oh my God. Find the distance of AB, BC, CD and AD and BD and AC. Use the distance formula 6 times. Listen, if all sides are equal and the diagonals are equal, it's a square. If opposite sides are equal, diagonals are equal, it's a rectangle. If opposite sides are equal, diagonals are not equal, no, it's a parallelogram. If all sides are equal, diagonals are not equal, it's a rhombus. Oh God. Listen, pointers, I'm just giving you pointers. All sides equal and diagonals equal, it is a square. Yeah, you have to use the distance formula and get hold of it. Second, if all sides are equal and diagonals are not equal, it's a rhombus. Next, if opposite sides are equal, yeah, opposite sides are equal and diagonals are also equal, it's a rectangle. And if opposite sides are equal and diagonals are not equal, it's a parallelogram. Remember, so 4 conditions. After that, you are in a position to decide whether this figure is any one of these. All right, so we're done with 3 more questions. Go through them. All right, the 21st question, beautiful question, beautiful. A, B and D are the vertices of a parallelogram. Find the vertex C. Class, you should know the concepts powerfully. So it's a parallelogram. A, B given, C not known, sorry. Let me call C as x comma y and D we know it. A is minus 1, 0. B is 1, 3. And D is 3, 5. What we can do is, it's a parallelogram. So the diagonals bisect. So obviously where the diagonals meet, that is the midpoint, which we can call it as M, x1, y1. So I will say that M is the midpoint of AC and BD both, because in a parallelogram the diagonals bisect at the center. Bisect means obviously M is the midpoint of both together. So let's find M with the help of BD. So I will start with M is the midpoint of BD. Using the midpoint formula, x1 is equal to 3 plus 1 upon 2. That's going to be 4 upon 2, which is 2. And y1 is equal to 5 plus 3 upon 2. 8 upon 2, which is going to be 4. So the coordinates of M are 2, 4. Perfect. Okay, now also I can say that M is the midpoint of AC also. So M is also a midpoint of AC. So using midpoint formula, yeah, x1 is equal to minus 1 plus x upon 2. We just have found out x1. This is your x1 and this is your y1. So can I say 2 is equals to minus 1 plus x upon 2, cross multiply. 4 is minus 1 plus x, shift. X is equals to 5. And talking about the y coordinate, y1 is equal to 0 plus y upon 2. This is your y1. Cross multiply. You get y as 8. So the coordinates of C are 5, 8. That's it. So we use the concept of diagonals bisecting in a parallelogram. Right. Let's go on with the 22nd question. The points, there are 3 points given. They are the midpoints of the sides of the triangle. Find the vertices. Bad sum. Horrible sum. Now what is given now? Vertices are not given. No. Midpoints are given. Let's say M, N and R. These are the midpoints of A, B and C. Usually what occurs is A, B, C is given. Find M and R. It's the reverse pattern. Midpoints are given. The midpoints are 2, minus 1. Minus 1, 4 and minus 2, 2. Let the 3 vertices be x1, y1, x2, y2 and x3, y3. I am not doing this entire sum. I will give you the gist. I am just working with the x coordinate. You can work by yourself with the y. Do the y part by yourself because it's a huge sum. Okay, let's start with the midpoint formula of AB. M is the midpoint of AB. N is the midpoint of BC. And R is the midpoint of AC. Fine with this? Alright. So use the midpoint formula. 2 is equal to x1 plus x2 upon 2. Cross multiply. 4 is equals to x1 plus x2. Chuck it. Leave it as equation number 1. Come on. Similarly. Minus 1 is equal to x2 plus x3 upon 2. Cross multiply. Minus 2 is equals to x2 plus x3. Equation 2. R, that is minus 2, is x1 plus x3 upon 2. Cross. Minus 4 is equal to x1 plus x3. Equation number 3. This is just for x. Similarly, you have to do for y also. It's not over. Listen. Add all the 3 equations. Add. So I can say, I'm going to do 1 plus 2 plus 3. So if you add x1 plus x2 plus x2 plus x3 plus x1 plus x3, when you add all of them, you get 2 x1 plus x2 plus x3. Ah, come on. 2x1 plus 2x2 plus 2x3. Take a 2 common. 4 minus 2 minus 4. I've just added the 3 equations. So you get x1 plus x2 plus x3 minus 2, and this entire 2 comes down. Minus 1. So the sum of all 3 is minus 1. If you want to find out x3, x1 plus x2 is 4. x1 plus x2 is 4, substitute. So 4 plus x3 is equal to minus 1. I'm repeating. The sum of all 3 is minus 1. Out of which x1 and 2 is 4. So out here, x1 plus x2, when you substitute 4, so 4 plus x3 is minus 1. So x3 is equal to minus 1 minus 4 minus 5. Similarly, what is x2 plus x3? Minus 2. x2 plus x3 is minus 2. Get x1 as it is. Instead of x2 plus x3, I put minus 2. So x1 is 2 minus 1, which is 1. And finally, x1 plus x3 is minus 4. Substitute. x1 plus x3, if you put minus 4, it goes on the other side. You get x2 as 3. Similarly, I have to solve for y1, y2 and y3. Such sums usually are not asked, but it's my duty to teach you certain concepts. Even if a sum won't come, but definitely this concept of adding all 3 should be in your brains. Right, so mark this as a star sum. Nice question. Okay, go through these 2 sums, many more to go still. Alright, question number 23. Points P, Q, R are collinear if Q lies between P and R such that PQ is 2 times QR. This is just a matter of just, misguiding me. It's nothing great in this sum. So in 23rd question, again we have PQR where I have been told Q is between P and R. Somewhere in between as of now. But a condition is given, PR is 2 times PQ. Hey, come on guys. This PR. If it is twice PQ, obviously Q is the midpoint. Therefore, can I say Q is the midpoint? And if Q is the midpoint, all I do is use the midpoint formula. That's it. So in this question, P is A comma minus 4. Q is minus 2 comma B. R is 0 comma 2. So starting from the center, minus 2 is equal to A plus 0 upon 2. Cross multiply, A is minus 4. And B is equals to minus 4 plus 2 upon 2. Minus 2 upon 2, which is minus 1. That's it. Next question. So the catch was only in this part. That PR is twice PQ. Indirectly, they are trying to tell me that Q is the midpoint. Collinearity, collinear means 3 points lie on a same straight line. That's the definition of collinearity. 24th. The question is, calculate the coordinates of the centroid of the triangle ABC where A, B, C are given to you all. Very kiddish question. We have done the formula. It's a direct formula application. A is 7 minus 2. B is 0, 1. And C is minus 1, 4. Let the centroid be G, X, comma, Y. We have a direct formula on centroid. X, always start from the center. X is equal to X1 plus X2 plus X3 upon 3. That's 7 minus 1, 6 upon 3, 2. Also, Y is equals to Y1 plus Y2 plus Y3 upon 3. 5 minus 2 is 3 upon 3, y is equals to 1. So my coordinates of the centroid are 2, 1. That's simple. In the exam, obviously, I expect you to define this is x1, y1, next to y2, x3, y3. Let the centroid be gxy. Write down the formula, it carries marks, right? Just application, that's it. Okay, so this ends our B exercise. Let's go with the C exercise straight away. So 2 more questions left, guys. Question number 25 and 26, yes? So we have taken all variety. I've got into the depth of this chapter for even the crash course. Because yeah, this chapter has the roots. Yes, they have the roots in the 11th and 12th. Very interesting chapter, important one. Right, the question is, the 25th question from my edge is, in what ratio is the line joining AB, right, where A is 0, 3 and B is 4, minus 1 divided by the x-axis. Not only that, write down the coordinates of the point where AB also intersects the x-axis. It's a simple question. So if I'm talking about the x-axis, this is your x-axis. Yes, we have a line AB. Let's say this is a line segment joining AB, where A point is 0, 3 and the B point is 4, minus 1. Find the ratio in which it divides the x-axis. Now, x-axis means this point lies on the x-axis, so the y coordinate has to be 0. So consider the point as P A, 0 and let the ratio of division be k:1. Because when the ratio is unknown, it's always k:1. So I can use section formula, midpoint and section formula chapter mein. I'm going to use section formula, internal division. So I can start this way. A is equal to, go crisscross, k into 0 plus 1 into 4 upon k plus 1. And on the same edge, 0 is equal to k into 3 plus 1 into minus 1 upon k plus 1. Cross multiply, or before I would rather find value of k. You get 3k minus 1, k plus 1 goes on the other side, cross multiply 0. So 3k minus 1, 1 is equal to 3k. So the value of k should be 1 over 3. Put the value of k in this equation. Yes. So I get a is equals to 0 plus 4. It's going to be 4 upon k plus 1. Put k as 1 by 3. So this will be 1 by 3 plus 1. LCM. 1 plus 3, 4. 4 upon 3, 4 gets cancelled. The value of A should be 3. Because that third line will go to the first line. Right? The last question, 26th one for you all. There is a diagram given to me in this question. Okay, a diagram looks something like this. This point is M, this point is P, the point B out here, and the point A out here. A coordinate is 0, 4 given. B coordinate 6, 0. Fine. And this is the origin 0, 0. And now in this question they are asking me, they are telling me that M is the midpoint of A and B, and M also divides line segment OP in the ratio 1:3. So guys, M is the midpoint of AB and M divides OP in the ratio 1:3. That's how it's given. Fine. Find the coordinates of M, right? Second, find the coordinates of P, and third, find the length of BP. The length of BP. Nice but simple question, a typical board question. Yeah. Now I can start this way. M is the midpoint of AB. So can we use the midpoint theorem, midpoint formula, and find the value or coordinates of M, right? So I can say M is the midpoint of line segment AB So using midpoint formula, x is equal to 0 plus 6 upon 2. And y is equal to 4 plus 0 upon 2. You get the value of x as 3 and you get the value of y as 2. So students, I have obtained the coordinates of m, which is 3, 2. So level 1 accomplished. So m I have obtained as 3, 2. Perfect. Now, once you get m, let me call p as x1 and y1 as my coordinates. Can I say m divides OP in the ratio 1:3? So students, m divides line segment OP in the ratio 1:3. Can I use section formula? Yes, internal division. So I'll start this way. X is equal to, go crisscross, 1 into x1 plus 3 into 0 upon 1 plus 3. And the center y is equal to 1 into y1 plus 3 into 0. So y is equal to 1 into y1 plus 3 into 0, yes, upon, again, the ratio 1 plus 3. Fine. So x is equals to, you get x1 upon 4 and y is equals to y1 upon 4. Alright, now that sounds perfect. Yes. Now tell me one thing, that I already have x and y as 3 and 2. So if you substitute 3 here and cross multiply, wouldn't x1 be 12? And wouldn't y1, 4 2s are 8? So the coordinates of that p should be 12, 8, right? The coordinates of p. And all I have to do is, once I obtain p, which is 12, 8, I can find the distance BP by using the distance formula. So come on, distance of BP, we have a formula, right? Distance formula, root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So on substitution, you get root of 12 minus 6 the whole square plus 8 minus 0 the whole square. So you get 12 minus 6 as 6 square plus 8 square. That's going to be root 100. So the distance distance BP is going to be 10 units. So guys, I guess that ends my chapter with you all on midpoint and section formula. Pretty simple question, pretty simple chapter. Nothing much. You have to just play within those boundaries. Few rules, few concepts, and I expect after 26 sums, you're definitely well versed and thorough with each and every concept. Right? Thanks, guys.